for that recording to start. Man. All right, so all right, so I do have tests graded for everybody that's taken them. Unless you took it yesterday or today, I will get those back to you ASAP. But if you have not, for whatever reason, taken that test from last week, I can't give grades back until you do. So I want to give them back in a very reasonable time frame. So hopefully we get that done. You probably know how you did. You probably know if you knew what you were doing or if you did. So let's do that, or it just stays as a 0. That's your grade, not mine. So, but I want to get you the best grade that possible. So we're only like a handful short, but still, it's a handful of people that are holding you back from knowing how you did. So that's kind of frustrating. But people are getting to get done, so that's I appreciate it. Yesterday we started something brand new, and I did not like the way that the recording looks. It did not capture it the way I expected it to, because I was using 3 different laptops at the same time and like moving cameras around. So I feel like what happened yesterday in class went really well, but you guys at home probably did not get much of an experience out of that. So I want to redo it, basically from scratch. Okay? And so what that means for you guys at home is that the next half hour or so is going to be exactly, if you were in class yesterday, is exactly what you just saw. But we are going to get to finish number 2. But if you want to, like, seriously, like, come back in like 15 minutes, that's fine. But come back because we're going to finish number 2. Or even like 20 minutes, okay? But I'm going to give you the copy. If you already printed one out, awesome. I have the copy for you. And if you did like follow along, great. This is going to be an easy start for you. But I feel like it's because it's brand new ideas, not super complicated ideas, but still brand new ones. I think it's worth the time on day 1, day 1B, follow it along, to start fresh. I have no idea. Just so that you can get some of these ideas down. Okay, so again, if you are at home and you were here yesterday in class, or you were virtual yesterday and you were able to follow along, take the next 15 minutes and do whatever you want, and then okay, we'll probably be in the middle of number 1, starting number 2 when you do that. Okay. Now, for you guys sitting in front of me, we're going to start this. But I think what would be helpful is not just having that piece of paper that I just gave you, but also having out a place in your notebook just to jot down a couple things along the way that will be useful to remember when we finish this handout and go to a different. Because there's just not enough space on that handout to write everything down. You're probably looking at that and be like, there's so much empty space in this handout. We're going to fill most of it. But we're only going to do 2 problems today. We're going to do number 1 and number 2 together. We're going to finish. And what we're looking at is actually a really short chapter, which I think is nice, since we just spent what feels like forever on quadratics in chapter 2. Seriously, this might only take us like a week. We will definitely finish this before spring break, but probably even before that. Okay, this chapter is about inverse functions. And I know we did it yesterday, but up until yesterday, this was brand new. Again, if you were good with yesterday, then this should just solidify all of those ideas. There's nothing bad about that. Some might make your life a little bit easier. But like, don't even care about the math part of things. Like, the only weird word up there is inverse. You know what a function is. What do you think of when you hear inverse whatever? Like, just make it simple in your mind. What does inverse kind of sound like to you? Not like syllable to syllable, but what does that word conjure up in your brain? Inverted. And so what does that kind of mean to you? Okay. Flipping. Okay. Build on it. Give me some synonyms for like that inversion, that flipping. Reverse, the opposite. That's all this is. we're going to be given some function. Our job is to find like the opposite function, like the complete opposite side. And so that's exactly what's going to happen. We're going to be given some function, all right? Whatever they're going to call it, f of x, g of x, h of x, even just y equals, right? Whatever they're going to call it. Who cares what letter they decide to use? And it's up to us to just find the inverse. The inverse of f of x, or the inverse of x. And I said this yesterday, I think, as I was talking to it. I forgot to mention it again in sixth period, but like math for math's sake is good for those of us that like it, but like what's the point in having an inverse function? It will save, and this is going to apply to a lot of your teacher careers, it saves half of the space of data storage in whatever kind of job you're doing. If I want to walk from my desk to Bryson, and then I want to walk back to here, I have to do both of those things. It takes twice the work. But if I had a way to walk to Bryson's and then teleport myself back by doing the opposites, I don't actually have to do all that work. And that's what inverse functions can do with data storage, is that if I have something that takes me in one direction, like Google Maps drives me from here to there, there's a way for something like Google Maps to say, when you say like, you know, that button that like flips them, right, on Google Maps, it has that like double-sided arrow and just like flip your origin and your destination. It's not recalculating the whole thing all over again. It's not using twice the data to do that. It's literally just undoing everything. It saves a ton of space in data storage. And I mean, there's a million applications of it, but that's just one, okay? But like writing all of those words out loud, if I like, when I get to my answer, I don't want to write all that. It would be really nice if instead we had some notation that does it. And we did. And it's a pretty simple one. It's a little misleading the way that it's written, but we didn't have a symbol for it, so we just kind of made one up. It still has the F, it still has the X. It just has a little -1, like up in the exponent kind of area. Same thing for the Y, right? Y with a little -1 on top. And that's not an exponent of -1. I'm not raising something to the negative first power. That's something else. This is just a symbol that means the inverse. And so you can read it out loud just like that. The inverse of f of x. Or you could say like you could read it in order. F inverse of x. Right? F inverse of x. Or y inverse. You can read it out loud however you want. But the idea is that when you get to the end, right? Because our job, they're going to give us a function. We're going to find the inverse. I want to let whoever is reading this know that, hey, this isn't just some y equal. This is a very specific one. It's the exact opposite of what you just did. What's so nice about this chapter is that I know it sounds kind of weird right now, but the processes are really simple, and it all comes down to this. And I cannot stress this enough. All we have to do, we're going to do it in a lot of different ways. All we have to do is switch x. I want to do the opposite. Well, let me start by switching everything. Right. Now, well, how do we actually do it, right? Let me get some pencils and some paper because I want to try this thing out. That's what that handout is there. Okay, we're going to do the first two together right now. Right? But you can see that there's like the function, and there's a lot of empty space, and then there's a graph at the bottom. I just didn't want to put the graph right underneath but like the actual function itself, because we have a little bit of writing some stuff down to do before we get to it. And what I think makes it easiest when you're dealing with when you're dealing with something like some equation, and we're going to graph the function, we're going to graph its inverse. I mean, it's a pretty simple function, but you know what shape that's going to make? If there's no squares or square roots or weird fractions or cubes or, you know what kind of graph that is? Y equals 3x minus 2. What's wrong with it? Pretty simple. Y equals mx plus b. Simple. The simplest two-dimensional shape, right? A straight line. That's all it is. But like, oh, I got to start at -2, and I got to go up 3 over 1, up 3 over 1. I don't want to have to necessarily like remember every single way that things are written. And so what might be really easy for us to do is if we can just like find a list of points that fit, then I'll just plot those, connect them, and move on with my life and not stress so much about it. But how do we do that easily? What is the best way, potentially, to come up with a table of values? Come back here. Any ideas what you think might be a really good way for us to not work hard, but work smart, if we know what function we have to deal with? I know, Carson. Thanks, buddy. I'm getting there. You're the man. What do you think? Any idea? What's a super, super, super fast way for somebody else to do all the work for me? Calculator. I'm going to rely solely on the calculator to help me out. Now, here's the thing. You might not have this calculator, okay? But if you do, take one out because I want to help you work through it. If you don't, a couple of guys from period 6 looked on the App Store to see if they could find an emulator that they like. I don't say to download it yet because I haven't done my research. Apparently, Calculator X kind of looks like that. The app called Calculator X. Now, I don't know if that's just Apple or Android or both. I'm going to do a little research and see if I can get back to you, because if you can download a graphing calculator emulator, then I can teach you how easy this is to use and save yourself a ton of time. Because if I just want to graph it, all I have to do is go to y equals top left-hand corner there, and that's where I am right now, and just type it in, 3x minus 2. That'll work. So top left-hand corner, all of these buttons up at the top, if I use my finger and draw on it, people at home can't see me. So if I use these buttons, I'll look for my arrow moving up there. All of those are all my graphing buttons. And I always start with the first one. All right, go to y equals, type in whatever you've got. Now, remember what we're trying to do, though. We're trying to graph it there. That was a space that was given to me. All right. Well, what space am I kind of stuck with then? Well, again, just look at my arrow. I can't really point because they won't see me. -10 to 10 in the x's, and then -10 to 10 from my left. And so if I want to graph this thing, it would be really nice if I didn't look at x's that were super, super huge in either direction, right? If that's the space that I'm working in, my x's and y's have to fit if it's worth writing down. You guys know where you can go to find a table of points just like that? Remember, points, the buttons at the top are where all the graphing buttons happen. And obviously a table of points would be really nice to help you graph. Well, so graph is going to give me the picture, right? And that's really nice because I can see that picture. And that's actually a -10 to 10, -10 to 10 window. Got to be careful, though. The graph on your paper is a square, but the screen on your calculator is a rectangle. Okay, this is stretched out.
I don't know after that.
Nice, right? That second button, either in blue on a newer calculator or yellow on an old one, right? That actually gets you into like all of these blue, or like I said, yellow on an old one, all of the blue options, right? So you could quit, you could draw stuff, whatever, square root, there it is. Do you see anything up in this top that you think would be good for us to look at a table of values? Yeah, there it is. But I know, but I like that you said graph because I just want to talk about it anyway. So I just went with it. But there's one thing I want to do first. Like second graph is awesome because that'll give me the table. But look at second window. TBL set. If I do second window, it will help me set up my table so it's ready to go. And I don't want to start at -3 if my x values start at -10, because I might miss out on some points. So I'm going to type in -10 instead. Now again, look at my arrow, not at what I'm pointing at. Down there is the negative next to the enter. That's subtraction. Those are two different buttons, read very different. Okay, so just be careful with that. But look, I want it, so that's a delta, that's a triangle looking thing. It means change. I want the change in my table to just be 1. I just want to go up by 1s, and I want it to automatically do everything for me. Now I can do what Caden was suggesting, go into the second graph and press the table, and there it is. I know, that's because you had me as your teacher. It's amazing. And that's okay, that's why I'm reteaching. But look at what your x values start at. Yeah, perfect, right? -10. But can I plot -10, -32 in this space? No. So I'm not going to write that down in my table if it's not a point that I can plot. What's the first set of points? There it is, starting at -2. Okay, so that's where my table is actually going to start. Now, here's the thing. These graphs go on forever, which means the table goes on forever. So if I just keep pressing the down arrow, I think that might help me focus in and realize, okay, there are some points down there that I like, but it's kind of, it's this collection of points from -2, -8, down to 410 that I think is worth actually playing. And if those are the points that fit, then those are the points I'm going to break. I'm going to go with my x's, -2, -1, 0, 1, 2, 4, 3, 4, and that will fit. And then the y's that go with them, -8, -5, -2, 1, 4, 7. And so in the space right below your function, right on that handout that you got today, write that down. Now, I got to disconnect. Go back to the front of my camera because I'm going to do something off the screen for the folks at home. Good thing I know how to use technology. My goodness, I cannot imagine being a teacher that is not good at this stuff because, gosh, teaching just is so hard. Sweet, there we go. And we'll plot those. We'll look at it for sure. Let me make sure my camera turned back on because just connecting it does not select it. There we go. Awesome. And we'll plot those points, connect and make it nice. But hey, while we're here, let's make a table of values for the inverse. But if I just write x and y, there is nothing telling me which one was the original and which one was the inverse. Now, yeah, sure, we read it left to right, so we can infer from the way it's written down. But let's take all of that ambiguity out and make it super, super obvious that we are talking about an inverse. So don't leave it as just xy. Put that little -1 up on top. Now, without a doubt, I know what my function is and what my inverse is. What do you think we should do to make this table of values? That's all we got to do. Literally, just switch them. Like, my entire x column is now my entire y column. Literally just switch them. And because we wrote them down in a nice order, I just stick with the order. All I have to do is take all of the x's, all of the y's, and switch. And there's my table for my inverse. Now, you guys said it. We have to graph a straight line. We cannot do that without some help. You have a ruler, take one out, otherwise you can use one of mine. Don't use those that are already used. I want to give you a clean one. The other thing that I think is really helpful when graphing, because we're going to graph both of these at the same time on the same set of axes, two different graphs, what I think is really helpful is a second color. Like pencil and something else. Anything else you want. If you need one, I will give you a colored pencil. These are clean. Pick one that is sharpened enough. We're only going to do it twice. You don't need much sharpening. But hey, why not? Pick your favorite. Yeah, that was nice. But a pen or a marker or another colored pencil or whatever you want. I think it just helps make things stand out. Yeah, and then I'm going to come back to the projector over here. We're going to grab them. Just one. Yep. Did you have a pencil and then whatever else? Pick your favorite. Make sure it's got a tip on it. Nice. Can you see some yellow there? Here you go. All right, cool. So now that we got some points, camera's coming off. Peace. You're coming with me. Oh, and down. This is what I did not do yesterday, and it really kind of hurt my chances at creating. Actually, you know what? Go like this. Set it up like that, and now let's graph them both. This. Sweet. And I'm just going to use those points, and that's all I really need, because anything else doesn't fit on this graph that's worth actually plotting, and we avoid like all the weird decimals and fractions because we're just going to connect the points anyway. So pick whatever color you want to start with. Maybe you pick your pencil as your first one. I'm going to pick blue, and I'm just going to go down that list, and I'm going to plot those points. Remember, your X's tell you how far left and right to go. Once you get there, figure out how far up and down you have to go on that line. So -2, okay, I'm there, down to -8, point. As big or as small as you'd like, not too big, of course, because we don't want it kind of leaking over into another spot. And fairly even right on that spot. And then just keep going. -1, -5, for point, 0, -2, 1, 1, 2, 4, 3, 7, and 4. And I know that there aren't any instructions on this. It doesn't tell you, hey, fill out a table. Hey, fill out the inverse. Hey, graph them both. I just didn't want to spill the beans early by writing the instructions down on this. I promise when we get to like the next round of this, once we're done practicing, I will say all of those things. Okay. And so cool, 7 points. That's as many points as I need. Really, I only needed 2 points, right? Y-intercept and the slope. Up 3 over 1. Up 3 over 1. There's my. But calculator does all the work. Now use your straight edge and connect them. The best way to connect it the best is to not line up like the first 2 or the second 2 or the last 2. It's to line up the first one and the last one, and all the other ones in the middle should fit. Okay, so I'm going to break out my straight edge. What do you guys think? It's pretty nice. No, I can't use this thing. This thing's like what? That will be my son's growth chart. I'm going to sand it, stain it, put it on my wall, make it into like a ruler, and track his growth. I did the same thing for my daughter. So Warburton hooked it up. So I have to freehand it because I'm not going to use that monstrosity. But you've got a straight edge. So line it up, do the best you can to make your nice little straight line connecting those points. Wow, not bad, right? It's my 4th time drawing that line in 2 days, so I'm doing all right. But are those the only points, or did we intentionally leave some off because they didn't fit? Right, we had to scroll through that table, all through all those points. So there's a lot more points that make up this line. This line keeps going. So what are we missing on this graph to show that line keeps going? Draw some arrows. Good. So this one's already at the top. So I just have to kind of like extend it, draw a little arrow. But this point down here, my camera's on. There we go. There we go. All right, so connect those points. Arrow up here is already at the edge. This one's not at the edge yet. Okay. But again, I couldn't plot a point at -3 because it was like down here at -11. So you want to extend this out, but you don't want to cross the next grid line. you don't put arrows in the middle of the graph. You put them on the edge. But if I did this instead, right, just kind of haphazardly threw an arrow on the end, then I am crossing this grid line and this one at points I'm not supposed to be, right? So be really, really, really careful. How far back are you going to let me go? Oh, there it is. Be really, really careful that when you do your extension on your own, that you stay inside that next grid line, whether it's left or right or up or down. Sweet. There's our function. It was just y. I'm just going to put a little y. Ooh, what is that? Now, switch colors and do the other one. So I'm looking at my second table, -8, -2. I switch colors from yellow to red. I'm just going to plot this next set of points. Now, really important, not as important with lines, because it doesn't matter what order you draw them in, but with like curves and stuff, the order that you write them is the order that we have to plot and connect them. And you're going to see why with number 2, that would create the wrong looking thing if we don't do it in the right order. And how look, 1, 1, we switch the point. Okay, still 1, 1, so that point is in common with both. So they'll run into each other. Most of these graphs will intersect. There we go. -8, -2, -5, -1, -2, 0, and so on. And then do the same thing. Line up your first point and your last point. And as best you can, make a nice straight line connecting. That was a good one. This point on the right is as far out as I need to be. So when I draw my arrow, I can just, little arrow out. But this point on the left is not at the edge yet. So when I extend it, I have to go all the way to the edge, but I just don't go to that next grid line underneath. If I was supposed to cross that line somewhere, I would have crossed that line with my point. Now that's my inverse. So find an arrow. Usually I just kind of find an arrow that's kind of off to the side somewhere and put y inverse. Okay. Nice to label, and you have different colors too, so that helps them stand out from one versus the other. But it does make it look really, really, really nice. Let me do that. This is low. Can I see the other story by how amazing it is? But I also want to highlight something else. Take a look. This looks great, right? Awesome. Labels, nice and straight as best you can, right? You can't be perfect. I'm not perfect. I'm not expecting you to be perfect. But there is something that does come up when you graph these. Take your paper. Actually, pick it up physically. Go ahead. Hold your hand. Now, staples on that top left-hand corner, right? What I want you to do is I want you to tilt the paper down towards that staple. You're like, hold the staple down, but don't go all the way upside down. That's 180 degrees. Don't even go 90. Don't go sideways. Just go 45. Basically, so that the top right-hand corner of this bottom graph and the bottom left-hand corner are right on top. Right. What do you see? What does it look like? Perfect X, right? And could you imagine drawing a line kind of right down the middle of that X that goes top left, top right-hand corner down to bottom right, and it would just split it right down the middle? That's actually going to happen every single time we graph a function that's inverse. And so what we're going to do every time, and I'm going to write this down in the front here in a second, top right-hand corner to bottom left-hand corner. Now, the reason this works is we're in a square, so I don't have to worry about weird spots. But top right-hand corner to bottom left-hand corner, that line that just kind of cuts through the middle, I'm going to dot or dash a line that acts as a line of symmetry. Now, you have a straight edge. It's a line, so use it to help. I have to freehand it. But the line y equals x, y-intercept of 0, slope of 1, is actually always the line of symmetry. I don't care what your initial starting function is. Because look what we're switching, y and x. Like you're basically saying, hey, y is now x and x is now y. And that line will cut it right down. And so we're always going to graph that. Okay, so I'm going to write that down here in the front. Come with me. I always try to choose the Blair Witch style photography. Oh God, oh, I'm lost in the woods. Oh my God. What a stupid movie. So great. Loved it. Okay, here it is. This is always, always, always true. Okay, your line of symmetry. This is the last thing that we'll kind of write down on this side of the note. Will always be y equals x. Okay, and it goes just top right-hand corner to the bottom left. And I'll tell you that. I'll say, hey, don't worry, like make sure you also graph the line. Okay. Now let's do the algebra that happens behind the scenes. This part you already know, so I feel pretty good. This part should go rather. I'm just rewriting it so I can work vertically. Cool. Find a table of points. Great. Calculator. Find a table for the inverse. Awesome. Just switch x and y. Graph it. Great. I have a table of points. I'll just plot them. Okay. Line of symmetry, y equals x. The last thing they're going to have us do is find the actual inverse, like as a function. If it's a function, at least as an equation, right? I want to find that y inverse, that f of whatever inverse. So, what do you think we should do? That's it, man, every time. Now, here's the problem. Sometimes it starts as f of x, right? And so if it starts as f of x, and so I call this step 0, because sometimes you don't have to actually do it, but sometimes you do. I think it's useful, and so if you like to write how-tos down, it's right here, how to find the inverse algebraically. Optional step 0, because sometimes you don't have to, is to write it as y equals instead of f of x. If I'm going to switch x and y, it better only have x and y in it instead of x and x. But this one's good, right? It's already y equals, so we're good to go. No big surprise. Real step number 1, switch x and y. And what do I mean? I mean literally switch them. Your x is now y and your y is now. And realistically, like that is the inverse. We just have to solve for y. We just have to get y by itself, just like we've solved for anything ever. Right? Y is on the right-hand side. We'll just move everything else to the left. The right side will get simpler. The left side will get more complicated. But you don't have to really like simplify. You just bring everything over. And so what do you think? What should we do first to get y by itself? Move stuff away from the right-hand side. What happens first? Busted. Right side just got simpler because now it only has 3y on that right hand side. What's the left hand side? 2. If you write it as 2x, that's connected by multiplication, so you want to be careful. It's connected by addition. So exactly as you just wrote it vertically, just write it sideways. X plus 2. Okay, cool. X plus 2. Now, if those are both numbers, fine. I put the numbers together, but one's an x, one's a number, so I just put them together and sweet. It's just a fraction. Now what? Get y by itself. Gotta break this out. How are they connected right now? What's the opposite? These are gone. The only thing you have left is y. That's what solve for y means. So I'm done. And look, there's your left side. Don't go crazy trying to simplify and break stuff apart and boom, done. Exactly just like that. Don't change it. The only thing that I want to do is let whoever's reading this know that x plus 2 over 3 thing over there, that fraction, that's my inverse from where I started. And so the last step that I'm going to do is I'm going to use that inverse notation. And I don't know, like for me, I like to have the y on the left and the x and stuff on the right. So I'm going to flip-flop it just so that it looks nicer to me. Like y equals whatever, stuff with x. You don't have to. You could have just done this and called yourself done. That's what we'll do. This doesn't look quite as nice. But that's it. And when I say that's it, I mean seriously, like that's the whole chapter. That's what we're going to do. We're going to get a table. We're going to flip them for the inverse. We'll graph them both. We'll draw our little line of symmetry, and then we'll do it algebraically. And I will tell you all of those things like step by step once we get enough practice under our belts so that you feel comfortable. Cool? Let's do number 2. Y equals x minus 2 squared minus 3. First thing to do, that's going to be longer than that, get ourselves a nice table of values. Okay, I want it to look something like this. And so what's the easiest way to get myself a nice table? Oh my goodness. I cannot tell you how many times I've done that last week. Moving around like this. I need to find myself a nice calculator, sit back, and watch them do all the work. Now I gotta move a little bit. Want me to share my screen? Nah, I mean if you want. I gotta come back anyway. You can if you want to help out. Thanks. So where do we go to type things in the calculator? If I want to graph like a y equal kind of equation. That's my question. Where do we go? So like, where do we start? Like, I want the calculator to know what my function is that I'm typing. Yeah, it starts y equals. I better click on that y equals. So I can get rid of this old one from the first one, right? So y equals. Clear it out. If you press delete, it's just going to go number by number by number. If you press clear, it just gets rid of everything. And then type it in. X minus 2 squared minus 9. Now, that table set, remember, we moved our table around. It changes the table set with it, right? I want to start at -10 and see if there's numbers at that spot that are worth plotting. Right? There's that graph. Oh, look, it's x minus 2 squared. It's quadratic. Yeah. Yeah, I am always going to give you that graph. Always, 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 so that you know you have some consistency. Now, that's me talking. I can't control what anybody else gives you. But in here, it's just me. So you're good. Yep. So always start at -10, but really what I'm starting at, Tave, I'm starting at that number. The first one on the left and seeing what it is. So if they only went -5 to 5, then I really only have to look in that space for points worth. But they started me at -10. There's that graph. Cool. That's quadratic. Makes sense. So -10. Now I look at my table. Yuck. Nope. 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 What x value is a good one to start at? Yeah, -2, right? -3 still too big with the 16. Now I want to see if there's any hidden ones down here. There's a bunch of them that are worth keeping track of. There we go. Those look good. I like that. Seems like a really good table from -2, 7 down to 6, 7. Okay, I'm going to write it. I'll leave that up for a second. So if you're writing, you don't have to wait for me to write it. But it's going to make a little table that goes from what, -2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 0, -5, -8, -9, -8, 5, 0. Some people in their tables, I get sloppy sometimes. Things kind of get wonky. Some people like to like draw some lines in here, especially if you're not on graph paper, just to keep themselves organized. It's kind of like a spreadsheet looking thing. That's up to you. You don't have to. For me, I gotta do sometimes. Now I'm going to detach from this projector back here, but the table is up at the front in case you need it still. I'll be back though. Cool. Got ourselves a nice little table. Handful of points or two, usually pretty good. We usually have like at least 5, but usually less than 10. But it depends on what we're looking at. The table will tell us, right? The calculator will tell us. Okay, now let's make a table for the inverse. I know it's going to be just as long. But, let me turn the camera on. There's something missing in this second table. I mean, obviously all the numbers, but there's something missing still. Hey. Yeah, letting them know what we're doing. Nice, good. A little -1. Okay, and so y inverse is how I read that out loud. And how do we build this table? How do I take that table on the left and make the table on the right? Switch X and Y. That's it. All of my X's are now my Y's. -2, -1, 0, 1, 2, 3, 4, 5, 6 in that order. Do not change the order in this, and you're going to see it's really crucial. Because look what happens with your Y's from the original, which are now your X's. Look, they start at 7. They start going down. I'm actually going from right on the graph to left. But then look, I go to -9, and then it turns and starts going back up again. Or back to the right, I guess I should say, because it's my X, Y. Right? And so if we don't do that well, if we don't pay attention to the order that it's written in and we just kind of haphazardly throw them in there, we're not going to know in what order to connect them. Because you're going to see with these kind of graphs, they're going to get all like sideways and weird and shaped kind of strange. We want to make sure that we're graphing them as best. Okay, so there you go. Take your, now I'm going to leave this. Take your X's and Y's and switch them. Now, let's graph it. And what's really nice is at this point, if you've got a table for both, just plot the points. Drop them on the right coordinates. We'll do the table on the graph on the right here, right? This is number 2. I'm going to stick with the blue for the first one, the red for the second one, whatever you want, works for me. And I just go through my first column. -2 up to 7. Okay. So go ahead, plot all your points. -1, 0, 0, -1, 1, -8. I'm just looking back at the table. Now, because it's quadratic, and how did I know it's quadratic? Well, it had the little squares on it, right? It's actually in vertex form right now. And oh, look, my vertex, here it is at 2, -9. No surprise. X minus 2 squared minus 9. But is that a straight line? Absolutely not. That thing is curved. You cannot use a straight edge to draw a curve. You just kind of have to freehand it. But you just want to do the best you can, right? I want to try to be like smooth, connected, symmetric, while also not stressing about trying to be perfect, because we can't. There's no way for us to draw a perfect graph by hand. And if you can do it, then please teach this class for me, because you are way smarter than me if you have that kind of skill. And again, like mine's not perfect. Now, maybe it bothers me that it's not as perfect as I want it to be. That's why we use pencil. Erase it. Do it again. I don't care. It's up to you. But we're missing something here. We got to keep going, right? Again, when you extend this out, stay inside that grid line, throw some arrows. When you extend, stay inside the next grid line, throw some arrows. We don't put arrows in the middle of the graph. We put them at the top, bottom, left, right, wherever. And that's why, right? So next to an arrow somewhere, put a little Y. No. If it was f of x, I'd put f of x. But now I got to switch. Now I got to do my inverse, but I have to plot them and connect them in that order if I want it to look right. 7, -2 is over there. 0, so don't go left or right, just go down to -1. -5, 0. -8, 1. -9, 2. But look, now it goes back. -8, 3. -5, 4. 0, 5. 2, 7, 6. The inverse of a function is not necessarily going to be, but it's okay. I just connect them in the order I plotted them. I would get the right picture. Again, extend it with some arrows. Just kind of follow the flow of the function that it would take you to extend it out. That's the inverse. So find a spot near an arrow. So it's easy to follow, a little y inverse, and then draw it into your line of symmetry, top right, go up. And usually, if you're doing this right, wherever they meet, to be exactly where that line is. So the two functions are meeting at some xy, and it's switched xy, that has to be the same number. Because x and y, switch them, still the same points, it had to be the same. There it is. And then take the page, turn it. What did you draw? What does that look like? Oh, happy late Valentine's Day. You do a hard math class today. There you go. We can draw some actually really cool pictures with functions and inverses because of the symmetry. Our brains crave it. Our brains want symmetry. That is why things like the Mona Lisa are considered so beautiful. There's actually a ton of mathematical symbols. Buildings are symmetric. Look for you. There's the human physiology. Cases that are symmetric. Great. Everything that's about symmetry is what our brain makes. I mean, look at the bricks, the concrete bricks on the wall, the blocks, right? There's symmetry to them. Now, it's obviously structurally strong that way, but it's also visually appealing. Cool, let's do it. Last one. Y equals x minus 2 squared minus 9. Let's find the inverse of this one. Is there already y equals? We always want to like pause for a second. Just like if it goes f of x, like it's kind of hard to switch those. That's kind of funky and weird to do. So I always just pause for a second, make sure it's y equals to start. Okay, cool. Now what do we do? Okay, hit me with it. Switch it. Always, always, always. Y becomes x. X becomes y. We do whatever we need to get that y that's now trapped somewhere on that right hand side. We just got to get it by. And so in your mind, or I don't know, some people, I like to write it down. It makes it really easy for me to keep track of what I need to do and in what order. When we solve, the easiest way, not the only way, but the easiest way, is to undo the subtraction, division, exponents and roots, and then work your way back from there. So that little minus 2 inside the parentheses with the squared on the outside, can we add 2 to both sides right now? If that with that minus 2 right here, can we do anything with this? That is trapped in here, inside a grouping symbol. We are looking for addition or subtraction that is by itself somewhere. Sounds good. Right side gets simpler, left side gets more complicated. Okay? Y minus 2 squared is the only thing left over on the left. And I mean, if you can simplify, great. You know, put numbers together, put x's together. If you got lots of stuff going on, then make your life simpler, but that's just x plus 9. Nothing I can do, but just rewrite it. And that's the case most of the time. I hate to say all the time, but most of the time. Cool. Addition, subtraction. Do we have any multiplication or division happening on that right side with y? Is there a number being multiplied or divided through everything? No. Okay, sweet. It's got a little easier. It's like when a is 1, right? We didn't have to do anything with that in that step. And that's kind of what we've got, right? Here's a right there. Okay, exponents and roots. All right, we have an exponent, so we want to undo that. So what's the opposite of squaring? Now, if you write that as a separate step, awesome. But if you want, you can just write it right on top, too. That's where the color, for me, really helps that kind of stand out. Because the square and the square root are just going to cancel each other out. And now the parentheses aren't even necessary because there's nothing on the outside. Right side just got simpler, as it always should. But what do you think the best way to write the square root of x plus 9 is? Just like that. Most of the time, we're really not going to do anything with the left side, but just like let it all happen. Whatever is happening to get the right side simpler, the left side just kind of takes all of that with it. But we just took the square root. So there is one thing we got to keep track of. There's one thing we have to add. Good. We have to make sure we have that plus or minus in front. We took the square root as part of our work, so there it is. Sweet. X minus root's done. Now we're inside the grouping symbol, right? That x minus 2, which is now y minus 2. Now we can do something with it. Yay, now I can add 2 to both sides. Gone. Y, sweet, by itself. Now that 9's trapped underneath. This 2's on the outside. Give me like 20 seconds. Can't do anything but write it nice. You can write it in this order, as long as you put the plus 2 kind of on the outside. Or I like to always put the nice stuff up front. The positive 2, I don't need the plus sign anymore. With the plus or minus the square root after. I am going to take the line of work and rewrite it to make it look real nice with that little -1 up on top of the y and switching sides. But if you want to just do this in red, that's cool. I like the one in black. Yay, we did it. Nice. We got the working. On your way out the door, if you borrowed a ruler or a colored pencil, please drop them in this bin so I can get them clean for you on your way out. Nothing you need to submit today, nothing you need to do for me, but show up tomorrow, and we'll do at least like 3 and 4, and we'll look next. Thanks, everybody. Have a good day. Remember homeroom tomorrow, and then I will see you in person again on Thursday. Folks at home, you guys are good. Any questions? Obviously, it was a lot of repetition from yesterday, but I know the people here definitely appreciate it. Yeah.